It's primarily based on my own research and several of the most recent books and papers that we have published. So it's basically an overview of the available techniques and methodologies, which I'm hoping will be of some use for especially graduate students who are attending this seminar. If you have any questions, feel free to ask me at any time. So I'm going to talk about two types of quantitative data analysis. I will start off by talking about statistical analysis or statistics that are commonly used in language assessment. Then I will cover machine learning and scientometrics. I have lumped together machine learning and scientometrics, even though they're not necessarily very much related to each other. So let's get started with statistics. I will talk about descriptive statistics and I will highlight their importance. Then general linear model, hierarchical linear model, factor analysis, and structural equation modeling. And finally, I touch on psychometrics in the first part. And in the machine learning, I will quickly walk you through some of the developments in the field of artificial intelligence and machine learning that have been used in language assessment. Okay, so first things first, as you know, if we collect some data for our research and we want to address any research questions, one of the first things that we need to look at is the quality of our data. And by quality of our data, I'm specifically referring to 4 measures, which are known as the 4 moments in statistics, the 4 basic moments in statistics. As you see, they're emboldened here. One of them is mean. Actually, I'm going to scribble a little bit. I have a very bad habit of scribbling on my computer, so I hope you don't mind. So the first one is mean. The second one is variance, and it's root square, which is standard deviation, and then skewness and kurtosis. These are the most important descriptive statistics that are often used, not only in the field of language assessment, but also beyond it. Why is, for example, skewness and kurtosis important? The reason is that we often collect data in order to make a generalization beyond the data set that we have collected. So it's not the data set that is important to us, but it's the extrapolation that we can draw, that we can make based on the data that we have collected beyond the current data set and to a population. So we want our data set, small one, to be a representative of a larger population out there. And as a result, it's very important to look into the features and the attributes of the data we've collected. The 2 most important measures that we need to look into are skewness on the one hand and kurtosis. So skewness is how tilted the data set is, and kurtosis is how high the data set is. And depending on what sort of criteria we take into account, we can draw conclusion as to whether the data is normally distributed or not. If the data is normally distributed, as you know, we go ahead and then conduct inferential statistics. By that, I mean the most commonly used in the field of applied linguistics, which is GLM or general linear model, and other types of analysis that assume normality. But if the data is not normally distributed, then we need to use non-parametric techniques. And there is a little bit more to this story, but at the interest of time, I'm not going to go through too much detail there. So out of these measures of central tendency, dispersion, distribution, etc., I would like to highlight these 4 moments and recommend that you always take them into account when you have a data and you want to analyze them. As always, as the first step, regardless of what kind of data analysis you want to carry out and what conclusions you want to draw from your data. Okay, so an example of descriptive statistics is when we analyze the mean score, which of the test items, which then becomes the item facility, or its inverse, which becomes the item difficulty index. This is under the classical test theory, or CTT. Sorry. So in the same way, we can look into the performance of raters as the first step to validate the rater performances. And we can look at, for example, the mean and the standard deviation, or the spreadness of the scores that the raters have assigned to for example, papers or oral presentations. Okay, now that we have, let's say, some evidence that the data is normally distributed, what should we do? There are some questions in research questions that would require the use of general linear models, and it's a big family. I'm sure you have read about them. Some of you might have already been using general linear models, and they consist of t-tests, ANOVAs and ANCOVAs, MANOVA and MANCOVA. ANOVA being the analysis of variance, ANCOVA being the analysis of covariance, and multivariate analysis of covariance and multivariate analysis of variance. Why do we use these techniques? Basically, all of these are regression models. So you can say that they are special types of regression models, and they're used for different purposes, primarily to predict the value of a continuous variable, that's y, as a linear function of one or more predictor variables or independent variables. For example, if you want to figure out whether there is a significant difference between males and females in terms of their listening ability or grammar or vocabulary scores, what you will use is a t-test, as you know. But if the number of levels in your independent variable is more than 2, for example, 3, let's say we have 3 types of citizenships, then we go ahead and use ANOVA. One of the cool things about GLM is that it allows us to partial out or to control for the effect of other external variables on our dependent variable. For example, you have a listening test on the one hand, and you want to figure out whether the performance of 3 classrooms are different with respect to the listening test. Now, you also have some evidence that their listening performance and as a result their test scores are affected by strategy. So you can use strategy as a covariant here, and basically using an ANCOVA test, you can adjust the mean of the listening score, that's to take away the effect of strategy use from the listening test, and then run the analysis. That becomes ANCOVA. And if you have more than two or more than 2 independent variables, what you will run will be a MANOVA, and if you have a covariate in the same way that I explained before, then that will be a MANCOVA. Now, these are very important for us, and you can add on the regression to this list. I didn't mention it here because all of these models are basically regressions. The importance of these models and analysis lies in the fact that after learning them, it will be much easier for us to learn more sophisticated techniques, such as structural equation modeling, because it draws heavily upon these techniques and factor analysis and a little bit of signal processing as well. Now, these models and analyses have assumptions. In addition to the assumption of normality, which I mentioned before, we need to make sure that the assumptions of these analyses are met. And unfortunately, there is a lot of research, some research, I wouldn't say a lot of research, but some research, review research shows that in applied linguistics and in fields like computer-assisted language learning, oftentimes these assumptions are not either reported or they have not been checked, or they have been partially addressed. So we have no idea whether the results would be reproducible or replicable. So you can take notes of the word reproducibility and replicability. I think you can take that into account as you are doing your research, because some research, mostly recent research in applied linguistics, has started to stress the significance of replicability and reproducibility. So back to GLM, what are those assumptions of GLM? First of all, we need to make sure that our dependent variables are continuous, not categorical. And if they are categorical, then a whole different type of techniques will be suitable for our data. As I mentioned before, we need to make sure that the data is normally distributed. There are 2 types of normality, univariate and multivariate. Bivariate is also a type of multivariate normality. So if you are running analysis, you can look at the Mahalanobis distance, or if you have access to software packages like Amos, you can look into Mardia's coefficient for multivariate normality statistics. What Mahalanobis distance can allow you to do is that it flags those outliers which are multivariate outliers, and it will allow you to see who is not going to be suitable for your analysis, and probably you have to think about how to deal with the group of people who are outlying. I'm not saying that you should necessarily destroy that part of the data, but it's important to take into account that the presence of outliers can affect the results of your analysis. Let's not forget the effect of sample size, because if samples are smaller than 30, at least, I mean, some people, different scholars have proposed different sample sizes, but a sample size around 30 is necessary to begin to give us reliable and consistent results. That's another point. Then dependent variables are independent from each other. We also need, as you know, to take into account the homogeneity of variances of different samples. And finally, if you are doing ANCOVA and MANCOVA, you need to consider the fact that there must be no dependency between dependent variables. In a publication, I'm just going to show the publication here. In a publication recently, my graduate student, Johan, and I reviewed methodological qualities of quantitative mobile assisted language learning research. And we found that a lot of these assumptions were not tested. So if you like to take a closer look at a source, I suggest this paper. I mean, it's a shameless advertising of my own work, but I think it might be of some use for some of you who are interested in this field. In addition, a book that we almost recently edited, the Quantitative Data Analysis for Language Assessment, Volumes 1 and 2, are full of examples about GLM and beyond GLM, and analysis beyond GLM. I go back to the previous slide. Here are 3 of the examples that I have chosen as examples of GLM. For example, BATI 2015 used a sample of 164 to run an ANOVA and a paired samples t-test. You can look at his methodology, is great, and I think it will provide you with a very good example. The other 2 examples that I would like to share with you have also used large sample sizes. Cobrin and colleagues in 2011, as well as Ling 2017, which has an impressively large number of participants in the study. They have used ANCOVA, ANOVA, for example, Cobrin with Bonferroni's adjustment for a variety of purposes. I suggest that you take a look at them if you want to familiarize yourself with how the data analysis has been used. Then comes factor analysis. I would like to very briefly present what factor analysis is. It's a reductionist technique. Imagine that you have administered 20 questionnaires to your students, or in some cases, a lot more than 20 questions are used in a questionnaire. So let's say 40 questions in your questionnaire. What factor analysis does for you is it clusters your items into what we call factors, and then factors represent a latent trait or latent variable, depending on whose terminology you would like to use. And then it will become much easier for you to make sense of the data. Instead of relying on single questions and students' performances on single questions, you can rely on factors. So 40, 30, or 20 items will be reduced into a handful of factors, which is more manageable and a lot easier to make sense of. There are some assumptions for factor analysis: linearity of the data, normality of the sample, and the relatively high degrees of correlations among variables. Factor analysis comes into 2 forms: exploratory factor analysis, that, like I said, it explores your data and then classifies your data into separate factors. Some of these factors might be highly correlated. Then confirmatory factor analysis is used in order to confirm or verify the model that has emerged from your exploratory factor analysis. So let's say you got 3 factors during EFA. You move those 3 factors to a different context and with a different group of people, different data set, and you fit a CFA, which has also 3 factors, in order to ascertain the reliability of the 3-factor model that you created. So you use EFA for identifying the model and CFA for confirming or verifying the model. But the important fact is that there must be two separate samples, both coming from the same population. As a result, both would be representative of the same population, but they have to be separate and independent from each other. And then it will allow you to provide some evidence for the reliability of the model that you're presenting. These are two of the examples. I'm not going to go through it in the interest of time. Then I would like to move to structural equation modeling. Well, for GLM, you can use observed variables. But now if you have got factors, for example, you've got a factor like motivation here, or stress, or positivity. This is real data we have collected in Singapore, and we are now working on a paper. I mean, so it's just like a sneak preview of the results that we have, a part of the results that we have achieved so far. So we want to find out the effect of motivation, not the items themselves, but the motivation as a latent trait on language performance. In the same way, we want to find out the effects of stress and positivity on the language performance of test takers here in our context in secondary schools in Singapore. And as you see, there is a sort of relationship between motivation and language and other latent variables in language. This is structural equation modeling. It allows us to find out the relationship between latent variables, but it's not limited to latent variables. You can include an observed variable, for example, gender, and find out whether gender affects your language performance latent variable, or it affects positivity, and so on and so forth. Now, there are different types of structural equation models. The one that you see in this picture is called covariance-based, or CB for short. Covariance, which is commonly used in language assessment. The assumptions of covariance-based, especially the one that uses maximum likelihood method of parameter estimation, is normal distribution, the absence of outliers, linearity, and uncorrelated error terms. Like, you cannot correlate these error terms here. These are error terms. Now, what if these assumptions are not met? There is another thing. So these are two examples of structural equation modeling. There's another technique called partial least squares, SEM, which is not as commonly used in language assessment, but I suggest that you take a look at it. It's very powerful. It allows you to circumvent the problems that I mentioned before. For example, if your data is not normally distributed, particularly if your sample size is small, a partial least square is one of the best methods of SEM that can be used for addressing those issues and problems. So this is Smart PLS, which is a software package which has been specifically developed for partial least square SEM. If you like to explore it, go ahead. I think you can download a trial version for 30 days. Now, most of the research that I have read, but not all, but most of the research that I've read so far in language testing focuses on students. But students are always nested within a class. So if, for example, research shows that the SES, or socioeconomic status of students, can affect their test performance. But research also shows that the socioeconomic status of people around you can also have an impact on your performance. We most often do not take this into account because most of the studies that we carry out are based on GLM or the linear structural equation models that I mentioned before. A hierarchical linear modeling is a great technique, and I highly recommend that you consider this for your research, because you'll find out how much of the variance that you observe in your data is attributed to the students themselves, how much of the variance is attributed to the variables that are beyond the student, and they have no control over them, but they do have an impact on their performance. For example, like I said, the SES of my classroom, the SES of the school, and the SES of the district from which in which the school is situated. All of these can affect my own performance, even though they are, as you see in this figure, they're way beyond my control and authority. They have an impact on my test score. So if you dissect a test score, a little bit of it or some part of it is a sort of variance that is representative of my own performance and my own abilities. a great part of it is not. And we need to know what that great part is. And using hierarchical linear modeling allows us to partition that variance and to figure out how much of other variables which are beyond the student can affect their performance. And it has enormous implications for fairness, justice, injustice, and validity, and concepts like that. If you like to talk about it more, I'm very happy to talk about it. These are some examples of HLM in language assessment. I can share the slides later with you. Don't worry about it. And psychometrics, I think I'm running out of time, so I just want to say that psychometrics usually refers to a group of techniques that allow us to measure students' performances. And by this, I just mean item response theory, Rush analysis, and cognitive diagnostic models. We use this to validate our test scores. And if you want to read a little bit about it, these are some papers, and they hopefully will give you some idea how psychometric has been used in language assessment. Last but not least is machine learning. Machine learning is a powerful device. We have two types of machine learning techniques. One of them is supervised learning, and the other one is unsupervised learning. Supervised learning is pretty much like regression models, in which we have a group of independent variables and one or more dependent variables. Within the linear and more familiar paradigm, which is commonly used in language assessment, we always want to create a linear relationship between the input, that's the independent variables, and the output, that's the dependent variable. So that linear relationship is usually expressed as a regression model. However, within the field of machine learning, you don't care about the linearity or whatever. You just say, I have some input, and I want to predict the output using this. And it becomes a very powerful concept in the sense that you do not restrict yourself and your analysis to linear modeling. There will be a lot of different nonlinear modelings, which will ultimately give you a high degree of confidence and precision in predicting your dependent variable. There are two types of supervised learning: classification and regression. We used classification in 2014 in a report for Michigan, and very recently Inami and Koizumi used a beautiful regression analysis, which is machine learning, and it's been published in the International Journal of Listening. You can take a look at it. I'm sure you will enjoy reading that paper. Unsupervised learning, on the other hand, is based on the concept of clustering, in which you have a group of variables, pretty much like factor analysis, in which you want to cluster things, but it goes way beyond factor analysis, and it often provides you with more precision. And I just wanted to say that there is an emerging field in applied linguistics, bibliometrics, and scientometrics. I've created quite a few videos on these concepts. So scientometrics is a technique to identify relationships between publications. For example, currently, I just give you this example and finish my presentation. Currently, I'm looking into the field of applied linguistics, and I want to see how is everything going on and what kind of research streams we have. So if I ask different professors in the field, they would give me different ideas. Although some of these ideas might converge, I'm sure that no one has read everything that's published in applied linguistics, because currently I'm looking at 20 top journals in the field, and I find that there are more than 27,000 papers. There's no way that I could read 27,000 papers. Therefore, Scientometrics comes into the picture. It mines the data for me, and it identifies the relationships between publications. It clusters them into separate clusters, and then it mines the clusters and then says this cluster is most likely about this concept, and the other cluster is more likely about another concept. So it provides a review, a data mining sort of review of the field of applied linguistics or anything else. This is a sample of one of the publications in System. I looked into the field of listening and reading assessment, and I found quite a few clusters that actually made a lot of sense. If you like to read the paper, feel free to go ahead. And that brings me to the end of this presentation. Thank you very much for your attention. Here are some sources for you, especially about the psychometrics, because I didn't go through it. The paper published in Language Testing is about Rush measurement. And here are the two books which I was referring to. You can find examples of the majority of the models that I have presented. I should say that I haven't presented, you know, a few other models like latent class models, which I think that was only at the interest of time. If you're interested to talk about it, I'll be very happy. And this is, I think, what Aline said, the YouTube channel. Feel free to go through the videos. They're all free. I don't know if you will find them useful, but if you do, please let me know. Thank you again for the invitation and your time. I'll be happy to answer your questions and take your suggestions.